Hello friends, welcome to Secret of Electronics. In this video, we will create a automatic room light with a bidirectional object counter which we made in our previous video. I posted a question in our channel's community section and received many requests to make this automatic room light controller project. The given circuit is a automatic room light controller with a bidirectional object counter designed using a 8985 microcontroller and IR proximity sensors. The circuit detects the entry and exit of pupil using two IR proximity sensors which are placed at the entrance of a room. These sensors provide output signals to the 8985 microcontroller with sensor 1 connected to PV0 and sensor 2 connected to PV1. The microcontroller processes these signals to count the number of people inside the room. When a person enters, the count increases, and when they exit, the count decreases. The microcontroller then determines whether the light should be turned on or off based on the count. The 8985 controls a BC547 NPN transistor through its PV2 pin, which acts as a electronic switch for the relay. When the count is greater than 0, the 8985 outputs a high signal to PV2, turning on the transistor. This energizes the 5-volt relay, closing its contacts and allowing AC 220-volt power to reach the connected lamp, thus turning it on. Conversely, when the count reaches 0, then the 8985 outputs a low signal, switching off the transistor and deactivating the relay, cutting off power to the lamp. A indicator LED is also included in the circuit, connected in series with a 220 ohm resistor to show the relay's activation status. Additionally, a 1N4007 diode is placed across the relay coil to protect the circuit from voltage spikes generated during switching. The entire circuit operates on a 5-volt power supply, ensuring smooth operation of the microcontroller, sensors, and relay driver. The provided Arduino code is designed for a automatic room light controller with a bidirectional object counter using a 8985 microcontroller and two IR proximity sensors. The program counts the number of people entering and exiting a room and controls a LED based on the count value. At the beginning of the program, the sensor 1 PV0 and sensor 2 PV1 pins are configured as a input pull-ups, meaning they are set to high band ideal. The LED underscore pin PV2, which is used to control the relay for the light, is configured as a output and initially set to low to ensure the light remains off at start. A global count variable is initialized to 0, tracking the number of people in the room. Two Boolean variables, sensor 1 underscore previous and sensor 2 underscore prev, are used to store the previous states of the sensors to detect transitions. Inside the loop function, the program continuously checks the current states of both IR sensors. If sensor 1 detects a object first transition from high to low, it waits until sensor 2 is triggered, indicating an entry. The count is then incremented and the update LED function is called to turn the LED on. If the count is greater than 0, 300 millisecond debounce delay is added to avoid false triggers. Similarly, if sensor 2 detects a object first transition from high to low, the program waits for sensor 1 to be triggered, indicating an exit. The count is decremented only if it is greater than 0, ensuring that the count never goes negative. Again, a debounce delay is added to avoid unwanted multiple triggers. The update LED function updates the LED status based on the current count. If the count is greater than 0, the LED is turned on, otherwise it is turned off. This ensures that the light remains on as long as there is at least one person in the room and turns off when the room becomes empty. The program includes a 500 millisecond delay at the end of each loop cycle to stabilize sensor readings. Now we will use the Arduino Nano board as a ISP programmer to upload code to the 8085 microcontroller. If you are not familiar with programming the 8085 using a Arduino Nano, you can watch our detailed tutorial by clicking the I button or by visiting our YouTube channel. Now connect the ISP pins of the 8085 microcontroller to the corresponding ISP pins of the Arduino Nano board according to the circuit diagram displayed on the screen. Now before programming the 8085 microcontroller, we need to upload the Arduino ISP program to the Arduino Nano board. I am not explaining how to upload the Arduino ISP program to the Arduino Nano because I have already uploaded it to my board. However, if you are not familiar with the process, then you can watch our detailed tutorial by visiting our YouTube channel. Now connect the Arduino Nano board to the PC using a USB cable. After connecting, open the Arduino IDE. Once the Arduino IDE is open, load the code file which you can download from the link provided in the description. After opening the code file, select the correct settings under the Tools menu. Once the correct settings are selected, click the Upload button in the Arduino IDE to upload the code to the 8085 microcontroller. Now that the code has been uploaded to the 8985 microcontroller, connect all the components according to the main circuit diagram discussed at the beginning of this tutorial. Initially the lamp remains off. Now you can see that when I move a object in front of both IR proximity sensors, then the lamp turns on. We can consider the object as a person. So at this moment, one person is present in the room and the lamp will remain on until the person leaves the room. When I move the object in the opposite direction in front of both sensors, then the lamp turns off. Now you can see that I move the object in front of both sensors 3 times. This means that 3 persons are now present in the room, so the lamp turns on and will remain on until all 3 persons leave the room. Now you can see that I moved the object 3 times in front of both sensors in the opposite direction, then the lamp turned off. If you liked this video, do not forget to subscribe to our YouTube channel to watch more upcoming interesting tutorials.